Hello everyone, welcome to our presentation on PulseShift, a real-time news recommendation system developed as part of our data center scale computing project. Our project team includes myself, Nidarshan, Parimala, and Aditya. Together we have collaborated to design and build a robust and a scalable system that eases the way of how users interact with news. The main objective of PulseShift is to address the growing problem of doom scrolling, where users get lost in endless and irrelevant content online, which leads to time wasting and distraction. So to solve this, we have deployed a system that delivers personalized real-time news recommendations, ensuring users see only what truly interests them. By analyzing users' behavior and preferences, our project organizes content efficiently and minimizes distractions and provides a seamless user experience. The system is built using microservices-based architecture on GCP. So this design makes PulseShift highly scalable, robust, and capable of handling heavy loads while maintaining key efficiency. To talk about the key accomplishments, by analyzing users' click rates and engagement pattern, we successfully deliver personalized news content that matches individual preferences. Next, the system fetches, processes, and updates news recommendation in real time, providing users with the latest information instantly. So our recommendation engine reduces the efforts for users by organizing content intelligently, ensuring an easy and enjoyable navigation experience. So talk about the software. For front end, the interface is built with HTML and CSS for styling and Flask for live integration. For the backend, JavaScript powers the backend, managing logic for processing user interactions. Next, the news API is API which is used to provide real-time news for multiple sources. And we have used Kafka for real-time data pipeline and streaming process, and BigQuery was used for the data warehousing part. So for the pre-processing half, we have used Apache Spark, and all the machine learning models are hosted in Databricks, which is used for the recommendation system. To talk about the cloud microservices, we have used Cloud Run and GKE, which mainly manages the containerized applications, and Cloud SQL, which is used for storing structured user data. Next, Cloud Storage has been used to manage the static website. And based on all this, we have used Looker for building dashboard. And to monitor and for the monitoring and logging process, we have used Cloud Monitoring and Logging System. Of the project, initially, the flow begins with a cloud-hosted front-end website that displays news articles along with a sign-up and a login functionalities. So user interactions are structured, and these are stored in primary cloud SQL database via the backend, which is built using JavaScript. The backend handles all functionalities, including user validations, and integrates with the news API to fetch and display news content dynamically. User clicks are captured and sent to the Kafka producer in real time. The Kafka is containerized and hosted on Google Kubernetes Engine. The live data stream flows through Kafka to the backend, where a Kafka consumer processes the data. This unstructured user interaction data is then pushed to the BigQuery, the data warehouse. So the further analysis will be continued by Paripla.
When a user interacts with a platform, such as clicking on a news article, the system captures the clickstream data through Kafka and stores it in a BigQuery. From there, the data moves to Databricks, where we use the ELT process to handle it. In this process, the raw data is first pulled from BigQuery using PySpark. Then it is loaded into Databricks for processing. We load, clean, organize, and enhance the data using PySpark. Using PySpark for distributed data processing allows us to handle large amounts of data smoothly. Where we train a content-based filtering model in Databricks. This model compares users' past activity with available articles to find the most relevant ones using techniques like cosine similarity. The model then generates a list of top 60 articles for each users, which is then sent back to BigQuery for storage. The system updates the recommendations. Databricks processes the new data immediately, and the For You tab is refreshed to show the most relevant articles. The updated recommendations are sent to the frontend via backend, which retrieves them from BigQuery using APIs. Finally, Looker is used to create detailed dashboards that provide insights into user interactions with the recommendations. These dashboards help track patterns such as clicks and preferences, evaluate the effectiveness of the recommendations, and identify the areas for improvement. Coming to testing and debugging. Debugging was an important part of making the system reliable. We use Docker to isolate services, create message queues to test early interactions, and use cloud logging to monitor issues in real time. Error handling methods like try-catch blocks and fallback workflows help to keep the system running smoothly. And debugging on GKE allowed us to fix issues step by step. For testing, we started with a local testing where each component, such as the front end, back end, Kafka, PySpark, and NoSQL database, was tested separately. Once they worked well on their own, we moved to integration testing, where we connected all the components and checked the data flow using clickstream data. During cloud migration and testing, we moved Kafka to GKE, deploying it in 3 zones to make the system scalable. We adjusted configurations and tested everything using the queue control and curl to make sure it worked properly. Finally, in user testing, we tested the entire journey from clicks to personalized recommendations to ensure everything was smooth and user-friendly. Coming to the bottlenecks, the major bottlenecks we encountered during development are handling new users and items, managing traffic spikes, and addressing processing delays. For new users, since we don't have the historical data, it is difficult to provide relevant recommendations. So we display default news initially, and we use Databricks to process user clicks in real time, which helped in generating personalized suggestions visible on the For You page. The future scope for the project is to increase the interaction. We aim to add features like article ratings, bookmarks, and sharings. Using these insights, we can improve the accuracy, personalization, and overall user experience. The demo will be further continued by Aditya.
User interface, which is the face of our app. It is built using Bootstrap and JavaScript for interactivity and responsiveness. The homepage is designed to show news organized into different tabs based on categories like sports, technology, business, health, etc. And each tab dynamically fetches data using API calls, ensuring that users always see the latest and the relevant news of their interest. For more engaging experience, we have also included carousels for the top 3 trending news. We have also implemented paginations. It is very noteworthy that we have used cloud storage buckets to host our front-end application because it's static and cost-effective, which is also scalable and gives a less user management. For ease of navigation, we have also included search bar, which allows users to look up specific topics. For example, if you search Manchester City, the personalization, which start with user signing up or logging in process. So as we can see that there is both sign up and login page that is being built. If the user is already signed up, they can just go ahead and log in. If not, I'll just quickly create a user for you all. So that it is very noteworthy that front end perform validations to ensure that the data is correct. For example, it checks if the password matches or not, for example. And if some random data, it should say it's wrong. Yeah. So let me create an actual user just to show you all how this works. Yeah, we are successfully there. So once there's a successful sign up, the data is sent to the backend, which is being containerized and run on the Cloud Run. We chose Cloud Run because it's serverless and support containerized workloads, and request process indeed sends the data to the indeed sends the data to the Cloud SQL, which stores the user data. So since the Cloud SQL doesn't have a way to visualize the tables and the users interactively, so we created an endpoint just for our testing purposes and to show it in the demo that as you see that it was initially 8 and now it has become 9, the user that we have recently created. The For You tab, since the user has not made any clicks or any dive into the heart of our system, real-time data streaming. Every news in our system is tagged with user clicks. So when a user clicks a news article, they are taken to a page displaying the full article. Simultaneously, this action triggers a Kafka producer in the backend, which captures the consumer needs to be listening to the port continuously, and the backend has to be constantly running the API processes. The user clicks and sends it to the Kafka consumer. The Kafka consumer is constantly running in the backend and processes and is subscribed to the same topic as the Kafka produces and processes the incoming data in the real time. For scalability and reliability, we have deployed 3 Kafka nodes on Google Kubernetes engine. This setup ensures high availability and automatic scaling and also load balancing. To make sure backend and Kafka consumer work simultaneously, we have also used multi-threading. The Kafka consumer then sends the click data to the BigQuery, where each query, this data is stored and used for further model training. Of our model training, let's talk about how our recommendation engine works. Our data pipeline follows ELT extract load transform rather than ETL because when user clicks on news article, the click data is extracted and sent to the BigQuery, and then the Databricks fetches the data from the BigQuery and perform the transformation using PySpark. We initially used the ETL approach where before loading the data into the BigQuery, we try to use PySpark to transform the data, but it was too much calls to the BigQuery and it was taking a lot of time. So to reduce latency, we started using ELT approach. For the recommendation algorithm, we use content-based recommendation. And the beauty of this algorithm is that only when the data is added to the BigQuery and it triggers this algorithm to run and then fetches the new data and stores the data back again to the BigQuery, as you can see here. Find more insights on the user behavior. We have also visualized the user clicks based on the record count, the category of the user, the base domain that each news is from, and the genre of each domain. So as you can see that as of now, we have about 3 to 4 users, and the no users who have not signed up for a page yet. We are calculating the record count for them. Finally, I just want to show a quick recommendation system that is already built for the existing user example. After successful sign up, you are taken to the homepage. Here you have the For You tab, and now you see that you are getting the personalized recommendation. Finally, I just want to highlight the role of cloud monitoring and cloud run logs in making all of these work. It would have been difficult to make everything work seamlessly without the logging and the monitoring experiences. For example, from the front-end user experience to the back-end intricate workflows, every component is designed to work in harmony, delivering a fast, reliable, and an engaging platform. Thank you.